Hello everyone! Today I want to talk a bit about how you can configure Schneider-Electric's analog output card, in particular AHO output card, BME Okay, let's get started. So this is my project in the Control Expert environment. Let me show you where my AHO card is. I got the PLC on hot standby. This is my setting here. So I've got two PLC on the hot standby on the dotted line here, and it's a ring. The CPU goes to a CRA card, and CRA cards where all the IO cards are. My AO cards are in here, and then the second port goes back to the B CPU on the hot standby, and so on. Okay, so move this away. So in the world of Schneider, the RIO or remote IO card is called extended IO bus. If we double click this guy here, it will show you all the layout of the IO itself. I'm going to close this hardware catalog. We don't really need it. So this is the card we're trying to configure. I've already configured all of this, and this is not configured yet. Let's go online with this PLC. Anyway, if you want to see CPU, you double click this guy here, and this is your CPU. There's no IO card in there. So in order to connect to your CPU, you go PLC address, and you enter the PLC address with a TCP and hit test connection. If it shows as a successful connection, you're ready to connect. This PLC's IP address, you can get it by double clicking the PLC bus here. And if you click on the Ethernet jacks here, this is a CPU. If you click not here, but here, if you click this guy here, they will show you the IP address. This is your IP address of your CPU PLC here. So I'm going to close the CPU section. So going back here, if I go PLC, that's where you put in your address here. So okay, and then now if this is good, you go connect. After a while, it will connect, and if you look at this setting here, you can see 9 is not configured. If it's configured correctly, this will show as white. Okay, so right now it's not configured, so let's get started. I'm configuring, so I'm gonna go offline here, disconnect. Anytime you need to do configuration of this capacity, you will need to do a full download. I'll tell you the reason why here. So if you go tools here, you go DMT. So every time you add, you're gonna have to add a card in here. Right now there's 1, 2, 3, 4. Let's expand this a bit. These are all analog input card. 1, 2, 3, 4. 1, 2, 3, 4. And this is your AHO card here. So you can see they assign an IP address every time you add a card. So with that being said, you're gonna have to do a full download. So let's get started here. You go right click here, add, and this is the card that we're after because it's AHO0412. Double click this guy here. Yes. And then my habit has always been identifying rack number and slot. This is slot 09. If you leave this blank, what happens is that the first one, it'll give you a name as that. The second one, they'll give you an alphanumeric suffix. So I don't really want that, so I normally assign my own, more intuitive. So rack 03, slot 09, which is here. Hit OK. You can see there'll be an entry coming here for AHO. This is the first AHO, which is this one here. Second AHO would be this one here. Okay, so first of all, you're gonna have to assign identifier. In order to assign an identifier, double click this guy here. Okay, and you're gonna have to go and click on your newly entered analog output card address setting, and this is where you have to assign an identifier. There's a bit involved in assigning identifier. The identifier can be assigned by rack ID and all that. So there's a user manual. If you open a trusty old Google here and you search for this text here, Schneider M580 creating device name DHCP, you'll come to a user manual. This is the title of the user manual. So and search for a text called create a device. It's on page I think 148. I think yes, 148. If I zoom in closer here, it'll tell you exactly how to assign your identifier, which is this thing here, right? So bring that manual up again. So I'm gonna bring up a notepad here. Okay, I know that my AO is on a CRA. How do I know? It's on a CRA rack and slot 9. So if I open up the manual here and a notepad here, so since my AO card is in CRA, it starts with C followed by 3 which stands for rack ID, right? So I'm just going to put C here, and I'm going to have to find out, it's capital C by the way, I have to go find out the rack ID here. How you find the rack ID? Double click this guy here, CRA ID, and you see that it's 00 without the underscore 001. That's your that's your CRA rack ID. So you open this guy here, and your manual is 001. That's your rack ID, followed by underscore and slot number. As you know, slot number is 9, so you have to prefix with 0. As you can see in this example, how they say that CRA 05 means it's in rack 1, slot 5. So I'm going to have to write 09 for mine because I got that 9 from here. And then followed by underscore and the model name. So my model name is AHO0412. AHO0412. Just like that, right? Just as a pointer, if your AHO, if it's your AHO or your analog output were to be on a PLC bus itself, if I open a PLC CPU here, let's say if your AHO is here, the way you write the ID would be, well, first of all, right, if it's a hot standby, and if you identify this as A and B, I have a tutorial on how to identify A and B and how you do it. It'll be on the top right hand corner of this video. So if you identify that as A and B, and let's say if this is your A, right, or let's say for the sake of discussion, this is your B. If your AO is on B, this is how you do it on the second one. So you're going to go M580. I'm going to open the manual here on the side. So it's on the B rack. So 580B, right, which is your rack ID, followed by underscore. And then I say it's going to be on slot 5, which is 05, underscore. And then followed by the model number of the card, which is AH00412. That's how you do it. If your AO card is on the main CPU rack itself. So for our case, it's not in here, it's on a CRA rack. So ours is going to be this guy here on top. So C, rack ID 001, slot 9, and the model number for the device, AH014. So I'm going to take this, copy in a clipboard, and I'm going to have to paste it in here. I want to show you how you get here again one more time. I'm going to close this again one more time. So if you go to a DTM browser, if you close this by accident, you go to Tools again, DTM browser, and you double click the one on top here, the CPU. It brings you up this one here, scroll all the way down, and this is your AHO that you recently added. You have one here, so here. Then you go address setting, go here, delete it, and control, and you paste it. I'm sorry, not control V. You paste it, and you hit enter. A pencil icon will appear on the left hand side to indicate that a modification has been done, right? Another thing that you all have to do is have to enable the DHCP so that the DHCP services is running, and hit apply. So that's how you set up the identifier. If you don't assign the identifier correctly, this thing is not going to work for you. So once you're done with this, you hit cancel to close the menu. So the next thing we'll do is we will disable the HART, right? So this is a AHO, it's a HART enable analog output. If you are only using 4 to 20 milliamps, there's no sense in paying extra for the HART enable AO module. You can get a cheaper option. It's is called BMX. It's an analog output. It's called BMX AMO0802. Check it out if you want to. This only does 4 to 20 milliamps. It's cheaper. You don't have to do this HART enable disable. You don't have to do any of this stuff that I'm showing you right now. So easier to configure. You don't have to deal with cybersecurity on DHCP forefront, you know, and it's naturally cheaper, like I said, right? So anyway, since this is a HART enabled device and you are only planning to use 4 to 20 milliamps, you're gonna have to disable the HART. In order to disable the HART, what you do is you go here and you go right click this guy, device menu, configuration. It will bring you to a menu where you can actually do all the configuration for the card. Go configuration, expand it, configuration parameters. There's 4 channel of HART, which is enabled by default. So go in here, disable. Note that make sure that you have a pencil next to it, so when you hit apply, that changes get applied. So you should have 4 pencils here. Once you get 4 pencils, hit apply and hit cancel. So you have assigned identifier for this card, and you have disabled the HART so far. So the next thing you want to do would be to compile it and download it, because you have to do a full download. Like I said, there's no way to not do full download. When you do full download, the PLC is going to stop. So with that being said, you know, a lot of things will go to default value in whatever you send. So one more thing I'd like to point out here is that there's this thing called fallback. So if your fallback is set to whatever value, here in future, if the PLC stops, like for example here, it goes to 0. Same goes for DO. On your DO is the same thing too, right? So it's just something to be aware of. Okay, so once that's downloaded, one thing I want to show you here right now is this. So I'm gonna put this on the side here, and then I'm gonna drag a window here, this one here. Okay, so if you open your browser and you punch in your IP address of a CPU, which you can get it again if I go back here to get the CPU IP address, open the CPU. This is a CPU. Double click on this Ethernet jack here, any one of them. This is the IP address of a CPU. You punch it in here, it brings you to a web page, and then after that, what you do is you go scan the status, status summary. Sorry, here. So you can see actually what's going on with all the CRA IO, right? So I know that, well, if you look at it here, so if this one here is my CPU IP address, how do I know? So I'll go back to CPU again, double click on that RJ45 jack, not out here, but here. Click here, you'll see that it has an IP address of 100. With those 3 ports, any of this IP address will work, right? But for some reason, on this ring network, that they've decided to use 100. So anyway, this is your IP address. You should be able to ping all of this IP address, including this one. This is my AHO, close this guy. This one here that I've been using. So how do you determine which one is wedge and where is wet? So if you go back to your EIO bus here, double click your CRA, you'll get a section on CRA. Click here, update IP DHCP. You'll get complete list of all the IP addresses that you have here. So for the sake of discussion, if I go to close this closer here, rack 3, rack 3 slot 3 is this, which is my AI card. So there's 4 of them. 1, 2, 3, 4 of them. The one I just added is this one here. So if you look at 95, 95, 95, 96, it's 96, 97, and 98, 97, 98. So these are my cards, right? And this is 99, which is your AO card. So if I try pinging all of them one by one, they should all talk except for 90, which is the newly added one. So if I go ping, 192.168.17. Start with 95, I guess, the very first of the row. 95 here. Let's go minimize it here, trying to fit everything into one window. Okay. You see it's responding, right? So it's responding. So we'll try 96, 97, and 98. 96, which is your second second AI card, slot 4. 96. This is 97. 97 is my slot 5 AI card. 98 is my slot 6 AI card. 98. They are all responding, right? And slot 7, if I go at EIO bus, 7 is your AO card itself. So AO card, although it shows an X here, oops, 99, although it shows an X here, it is working. Let me show you here, 99. See, it responds. So everything is good. It's just that this is an AO card and it's supposed to be, something's supposed to be hooked up. That's why it's not configured correctly. That's what they're saying. But if you go back, if you go online, if I showed you previously, if you go online to this controller, you will see that 7 is actually white. Okay, let me show you. What I'll do is I'll do build. Okay, once the build is done, right, you go online with the controller. The controller is saying that the program that's on my computer is different. Let me close this, is a bit distracting. The controller, what's in the controller is different from what's on this PL in the program here. So you're gonna have to download. So one thing you have to look at it here as we download is that everything will go offline except for this one here. And then you'll see one extra one being added here, which is our new AO0412 card. And let's do that right now. Transfer PLC. Hit OK to run, and everything is coming online here. Okay, we know the IP address of this is 90, as we've seen just now. Another way to look at it is if you go to your CRA again, click on this guy again, and we know slot 9 is our new one, 90. So I'm going to close this guy here, close this here, and if I try pinging my 90, which is a newly added one, it will respond. Okay. Okay, that's so another one more demonstration that I wanted to do was to the wire card. So if I, let's say, open this guy here, one neat feature, I guess this, I don't think we need this anymore. I'm going to push this away, make it a full screen. This wire control, by default, it is not checked. If you put a check here, what it does is that it checks for wire breaks, right? If you put check here, it means that if there's a broken wire, that will be faulted. So right now on this PLC, nothing is connected, right? If I were to put a check here, right, like that, right, and then you have to hit validate. Well, if you don't have this menu, it's a menu here that you, if you don't have this menu to validate, right click here, edit. That's how you edit, right? That's how you right click. So you're gonna have to validate it, and it says that you will have to go offline, modify it, which means you have to download it again, and so on. So I'm gonna do it anyway. So you can see that I'm gonna call the web page back again. Here, you will see that the this will turn red because it's checking for broken wires, but this will still maintain red too. Let me show you. I'll compile. I need to go offline first, and then I need to go build. Okay, once the build is complete, connect to the PLC, and then download to the PLC. Run it. You will see everything will turn white except 9. There you go. So it's checking for broken wire, and like I said, there's nothing connected to this except that the wire goes to a terminal block and it stops there. Another thing to note is that the bus do indicates there's some issues with this connection here. So you look at it, naturally this is not talking. Again, this is what it looks like on the web page, and this is what it looks like on the rack here. Another one more thing before I close this, I would like to talk a bit about the AMO card and the BMX AMO card, the one with only 4 to 20 milliamps, and the AHO0412 card. So the key thing is that if you don't really need HART, or if there's no plan in the future to add HART transmitters, this doesn't really make any sense to pay that extra money to buy a AHO card, right? You know what I'm saying? Like the problem with the AHO card is that you're gonna have to do all this configuration, make sure your identifier is correct. It's a bit tedious, the configuration, but you have to configure it once and you're done. But if you add a new AHO card, you have to make sure that they are all configured correctly, the HART is disabled and all that. If you don't do that, it will not work. So a certain level of training is required. Configuration is a bit tedious, and you need to be able to configure that. Secondly, like I say, it's a cost, right? It's slightly more expensive, the AHO card. While on the other hand, this, let me bring this down here, this, what do you call it, AMO card here, BMX AMO card, is cheaper because it only supports 4 to 20 milliamps. Like I said, it depends on your needs and your future expandability, right? And the second part is that if you get an AHO card, like this is called BME AHO 0412, and this is called BMX AMO 0802. With the AHO card here, you have to be aware that a bit about network settings and cybersecurity, because all the data are being exchanged through Ethernet. So if you, let's say for example, for me, what I did was that I hook up this controls network to the corporate network, and what I had was that the corporate network naturally had a DHCP server, and my M580 has a DHCP server. So both of those servers were fighting with each other to assign IP address. And what was happening, the symptom for that was that this is the CPU and this is the CRA. CPU will come on, everything will show access, right? But after anywhere from 5 minutes to 2 hours, your CRA will go check green, which means something to do with TTL or something. The packets eventually give in, and then eventually you'll have CPU good, CRA good, but everything else will be X as in faulted. And if you look at your rack, 3, 4, 5, 6, 7, everything will be X as in faulted, right? So that took me about 2 days with Schneider-Electric technical team to actually help me resolve that problem, mainly because I'm programming remotely. So yeah, I had those problems, and like I said, if you don't really need that HART configuration, I would recommend you to go with that 420 milliamp only AO card, like this guy here, right? Anyway, and the last thing before I go is that don't forget to if you don't need if you don't need this fallback, sorry, if you don't need, expand this, if you don't need this guy here, make sure that you remove it, enable it, validate it, and then after that you build it, and then you download it, transfer it to the PLC. I hope this configuration guide will be helpful to you, I guess, and hope you won't get stuck like I did for 2 days. Anyway, we have a good day.